read it. The line goes on in one direction. So the next one. Let's see.
So pretty.
Yeah. Next one. Let's see, next one.
Oh, that's good. That's I like it one. Oh, we got some 19-year-old Harry coming along.
Their hair.
Like I can't not.
The hair dryer one's the funniest one. That one's hysterical.
Yeah, it's in Japan.
Yeah.
No, him and Dunkirk was the best thing.
Yes, I agree.
Also, I just love that.
When I taught at a co-ed school, I had like this cute little couple. They're not together anymore. They graduated from college now, but they were different years. But in my calculus class, I had like Angie, who was a junior, and Zach, who was a senior, and they had been like dating through high school. But he came to me one day and he's like, "Can I ask her to prom on the slides?" And so he had like Harry Styles. Every time we did Harry Styles, he would get jealous because she would just like all the girls, including her the most, would be just like, "Oh my god." And so on the last slide, it was a picture of him with like Harry's face like next to him. It was really sweet.
That's
Now that I think about it, I had people ask for prom and homecoming. First of all, happy birthday. I'll tell you. Yeah. Okay, so oh no, don't not be oriented. Let's see. Okay, it's working. All right, we're going to move on down to this one for right now. All right, raise your hand if you have a question to us. Honors Pre-Cal, this is review. When I was in pre-calculus and my teacher said that, I'm like, I didn't really learn some of this stuff very well. So please feel free to ask questions, okay? Isabel?
Yeah, Isabel.
Okay.
Can we do the last question, 28?
All right, 28. All right, so, oh, yeah. You know what? That's something called partial fractions, and that's a great question. By the way, always email me if you get to something that you feel like I haven't taught you yet, and I might say, too bad, I wanted you to look it up and try so that this I would have actually given you some direction on. I didn't realize that 28 was like that. Once you looked at the solution, you probably could add them together and verify that that was true. So I'm going to go through this really fast. If you want to write yourself a note on 28, I would not ask this on the test. However, those of you that go into BC, which will be a lot of you, you'll have to know how to do this. It's called partial fractions. It's kind of a weird thing. In calculus, we got to be able to put things together and pull them apart as an engineer, okay, for lack of a better word, or that's a really good word. So many times, like for instance, if you ask all of us in one sitting, if you just got off our math teachers looking at this and said, okay, now take the integral of that. You may have heard that word before. There's derivatives and integrals. Integrals are extremely important. We'd all look at you and go, oh, well, I actually could do that one. But many of them I couldn't take. I would just look at you and go, I can't do it. Rational functions, but I could if I could pull it apart. And you spent your whole career so far putting it back together. But now I'm going to pull it apart, okay? So I'm going to go in and show you because I let it out there. And maybe a bonus or something one day. So what you're thinking is if this factors into x plus 2 and x plus 1. To do partial fractions, you say something over x plus 2 plus something over x plus 1 added together to give me this result. And some of you I'm super duper bright. Some of you may have actually thought through all of this. If you really put your thinking cap on, which you better get used to heading into the rest of honors Pre-Cal and AP Calculus, but you're going to be among people that do. Do you at least understand what I've done here if you didn't think of it yourself? I'm like, I already got the result. What happened to make me get there? And so I just picked two fractions that had to add together to be that. I don't know what A and B are yet. It could be 3 over x plus 2, and I don't know what they are, okay? One question that people ask here, and I'm skating over this, and thank you for listening, although even though I've already done like the cardinal rule that teachers should never do and say this isn't on the test, but hopefully you also heard the word, hopefully I remember to make it a bonus one day, which some of you already need, because of homework checks. But anyway, back to this. Just a whole lot of this is common sense. Oh, I know what I was going to say. What a lot of times people ask me is, how do you know which one to put first? Like, suppose that one of you had factored it x plus 1 times x plus 2. I mean, you could have, right? It wouldn't matter. You just stay with what you said, okay? And we should all end up with the same answer at the end. So if you put a over x plus 1 and b over x plus 2, all of our numbers at the end are going to end up being what they need to be. I don't know if that makes sense or not. Okay. So now I'm going to work it like your homework. I'm going to get a common denominator to try to build this. So I'm going to squish these together. And what do I need to multiply this one by? X plus 1. What do I need to multiply this one by? X plus 2. And I'm trying to force it to be 2x plus 3 over x squared plus 3x plus 2. All right, I'm going to come up here, and I'll do it in Harry's hair. If I say I have a super secret number, you would have to do a little work to find that number, wouldn't you? Cross multiply and solve for x. But what if I said I have a super secret number? I don't have to do anything. I hope you don't either. What is it? 7. It's not that secret, is it? If the denominators are the same, what could you say about the numerators? They have to be the same or they wouldn't be equal, right? So what I'm going to do now is I'm going to say, okay, can y'all see that now my denominators are the same? So I'm going to ignore them. I'm actually going to erase them. And now I'm going to say these numerators have to be the same. Now we go to your Algebra 1 and Algebra 2. And we think about how to solve what's called a system of equations. You've got a lot going on in here, okay? So you actually fill in any number that you want to. I could go, Lindsay, give me a number for x. And if she said 3, I would have something like 4a plus 5b equals 9, okay? And then I could ask Lauren to give me a number for x, and I would have another a plus b, and I could do elimination and substitution. You could do this, okay, to finish it up. But there's really some super easy numbers to fill in to make our life even easier. I call these all your most important numbers. Anybody have a guess what they are?
That's 0, 1.
Bella?
Bella. 0.
0 is a great number.
5 sometimes.
Okay, but look, what would make this even easier? 0 is always a great number to fill in. But I'm still going to have an A and a B and a number. The most important numbers, whenever I say that in here, will be like their factors. It's what makes it 0. What makes this 0? What makes that 0? It usually makes your life a whole lot easier to find what makes it 0 in a lot of ways, okay? So I'm going to fill in x equals -1. I could do your other suggestions and everything would work out fine, but here I get to avoid a system of equations, okay? If I fill in -1 for A, fill in -1 for x everywhere, what happens to A?
0.
It goes away, and I get 1b equals 1. Check my math. I'm not really good at easy math. Sorry. So b equals 1. And now I'm going to go back to this statement, and guess what I'm going to fill in for x? Now I'm going to fill in -2. If I fill in -2 here, I get -a. What happens here? 0 equals, I'm filling in -2 everywhere there's an x, -1. So, oh wow, a is also 1. And so my answer to the problem is to pull this apart. This is called partial fractions. That would have equaled 1 over x plus 2 plus 1 over x plus 1. Is that what they had? Yeah. Okay. I'm not going to take time to do it right now, but guess what would happen if I then added those together? I should get that. They should share every point, every asymptote, everything. Okay? Now that's super easy to take an integral off, but you don't care right now. But now all of a sudden it enables me to pull it apart, and then it's a whole lot easier next year if you're in BC. This is unusual in that A and B both are 1. A could have been 7 and B could have been -2/3. That's anything can happen. But whatever letter you put over your factor we'd all get the same answer in the end. So anyway, just now that you know it might be a bonus, I hope I remember to give it to you one day, just maybe as you walk in and get ready for class or whatever. If I have one, you pull it apart into something over one of the factors plus something else over one of the factors. There's a lot more to this, so that's an intro to partial fractions. But I usually get the intro to partial fractions to my BC students, so you're already ahead of the game accidentally. So anyway, so that was number 28. Always email me with questions like that, though. You'll be surprised at how quickly I answer. Then I send out if all of a sudden I realize something like that, the whole class will get a statement about it, okay? Either don't do 28 or here's how you do 28 or something like that, okay? All right, great question. Other questions? Okay, Lauren?
I have a question.
Oh. I'm coming to you next. Her hand beat yours, okay? All right, this is number 12. All right, going to 12. Maybe if it goes, let's see. All right, 12 is 5 over n plus 5 plus 4n over 2n plus 6. You could factor out a 2 of the n plus 6, but it's not really necessary now. It might be necessary later to get the final answer. I'm going to work it 2 different ways, girls, okay? And one of them I would suggest over the others, just teaching you to think broadly about the big picture. I already know where the asymptotes are here and stuff like that, okay? One option is just to not notice there was anything in common in the second one, which I hope you won't do again, okay? So a lot of you probably did n plus 5 times 2n plus 6. So I need to multiply this by 2n plus 6. Are y'all okay with this so far? And this one by n plus 5. And then the things that can catch you on this are negatives and distribution, so be really careful. All right, so this becomes 10n squared plus 5n. Oh, wasn't it the other day I made all those mazillion mistakes? Okay, I have an excuse for that. I don't think I told y'all about my foot on Thursday. Did I? It wasn't. It was a staph infection. I went to I had to go to another doctor because my foot was as big as my head literally by the time I left school, and I considered be putting in the hospital on an antibiotic IV, but he just gave me bunches of antibiotics. So anyway, that's my excuse for being real distracted the other day. Hopefully I hadn't made a mistake yet today. I'm sure I will after saying all that. Okay. So anyway, so far so good. So you have 14n squared plus 25n. I've already messed something up. This is 5. So after all that big speech and all that excuse, let me go back and be careful. All right. Oh, that was right. 10n squared.
No, it's just 10.
Yeah, just 10.
10n. Thank you. 10n plus 5. All right. Plus 4n squared. The reason I knew I had made a mistake after saying that I wasn't going to make any is I know.
Wait, is it plus 30?
Oh, I can't read my own writing. I thought that was a 1. What is that little thing? I don't know how to move that. I don't know what I just did. All right, 2n plus 6. Oh. Anyway. Hang on, let me see if I can get this right. Plus 30 plus 4n squared plus 20n. Pietra?
I just have a question. So in like the second, like after the plus sign, like 4n over 2n plus 6, can you simplify first?
Yeah, I already said all that.
Oh, okay.
I'm going to do it 2 different ways.
Okay.
I would rather you be aware of the big picture that you could simplify before you go. Because I will always want you to simplify first if you see it, because your numbers are smaller and you've done it at the beginning rather than the end. So that's great. Be aware of that, but I was afraid a lot of people weren't yet.
Okay.
But that's why I knew that I kept making some sort of mistake as I was talking to y'all, because I knew that there'd be something in common that I could factor out. So this is 4n squared plus 30n plus 30 supposedly over n plus 5 times 2n plus 6. All right, now pause at the end and go, but is there anything in common here? On the bottom, I actually have n plus 5 times 2 times n plus 3. That's really important. On the top, I can factor out a 2, and that gives me 2n squared plus 15n plus 15. What cancels out? The 2's. And so I have 2n squared plus 15n plus 15. What number was this?
12.
I'm just checking my answer. Over n plus 5 times n plus 3. Now what? Mike, I can't imagine it would happen, but isn't there a chance that this would then factor and you could cancel some more?
Yes.
You could do the b squared minus 4ac real quickly to see if it would factor or not if you get a perfect square. Okay? I don't think it factors. I think we're done. All right, so Lauren, yeah, it's really hard to see, I think, right here that was even going to happen until somebody tells you to be aware of it. Like, oh, watch out for that. All right, now, I said I was going to do it 2 different ways, so I'm going to go through this really fast. I've already messed it up. At least I caught myself. All right, so we're going to go back and do what Pietra said, which I highly recommend. Be on the lookout. The bottom, please always be looking for things that are in common. It makes your life easier. Isabel?
For the test, would you like us to factor it even if like nothing cancels out with the denominator? 'Cause,
No,
like,
you don't have to.
Oh, okay.
But if you miss it, then you just haven't reduced it all the way, and I'll give you partial credit. Okay. That's a great question too. There's no point in, if it doesn't cancel, there's no point in having it factored, other than you find x-intercepts or something. At the top, I mean, that's just up to you. Okay, so here what Pietra is referring to is 2 goes into 4 2 times. So I have 2n over n plus 3. We've got to talk a lot about things we can cancel. Girls, I cannot do this. I'm going to do it in red. I cannot do this. Okay? I cannot cancel those n's because I would say the one on the bottom is not an n. Okay? I know that sounds kind of weird. But when you're adding and subtracting things together, I think I've already told you it acts like glue. Okay? Suppose I have x over x plus 3. And let's say if x is 2. I see students like come in here and cross this stuff out all the time and say their answer is 1/3. Okay? I would say that bottom is not even an x. If you fill in 2 on the top and 2 on the bottom, you don't get anything related to 2 or 3. Do y'all see what I mean? When you're adding and subtracting, those are stuck together. Guess what the only thing you can cancel with an x plus 3 is an x plus 3. Also with numbers. What if I have 2n plus 6 over 3? Can I go 3 goes into 6 2 times? Order of operation, you got to figure out what that is first. Okay? I would say that's not a 6. It could end up being anything when you add it to 2n. So just be aware of that. We can talk about all that. The reason I could cancel out that 2 is, do you see I factored it out? And it applied to that whole thing. All right, then my common denominator is a little easier. 5 times n plus 3 plus 2n times n plus 5. I didn't cross multiply, by the way, girls. I'm doing this in my head. I'm multiplying this by n plus 3, and I'm multiplying this by n plus 5. So on the bottom, this gives me n plus 3 times n plus 5. And I believe if you do all of this, that'll give you right here 2n squared, right there. This is going to give you 10n, and 5n is 15n. And this is going to give you 15. I don't think you can see that very well, but it's the same answer here. All right, Isabella? Am I calling you the right name? Did you have your hand up?
No, but I think.
Okay. I'm not going to always do problems two different ways, but then you like the second way better. Reduce beforehand because you might not even catch it at the end. Yeah. Also, these graphs look the same, but these numbers might be twice as big. I'm sorry, if you didn't catch it, if you were trying to graph this one. I mean, the numbers won't be twice as big. You just find more convenient numbers with a reduced one. The numbers ought to be the exact same. So Lauren, that's probably what you were alluding to, like their answer was a reduced answer of maybe the one you had. I'm gonna go to, unless you have a question on this, I'm gonna go to, okay, go ahead.
Why is it 2 ends, not 2 squares? After you.
Oh, I really put that in a really ugly place. That was my fault. Here, I had factored out the 2, and on the top we had a 4 in. And so in my sloppy writing, 2 goes into 4. I probably should have done that. By the way I threw it up there, it looked like an n squared. Sorry about that. Do you see, I'm just saying, I'm canceling the 2 and the 4. It has to have it in common. The 2n plus 6 both had a 2 in it. Okay, Elena?
Number 17.
All right, so this is number 17.
I can read it out.
I got it right here. One of the few times I'm ultra prepared. All right, so 17 is 3 over 8, that one, minus 3 over 3x plus 4. Okay, I'm looking to see if there's anything in common, like see that 3 on the top and some 3's on the bottom. But does the 4 have anything to do with the 3? If that said 3x plus 9, I would do what Pietra suggested in the last one, or 3x plus 6 or something. There's nothing I can reduce, so now I'm going to go forward. All right, Elaine, I thought that my common denominator was 8 and 3x plus 4.
Yeah.
So I'm going to multiply the 3 by 3x plus 8 plus 4. I'm going to multiply this 3 by 8. So this one I had to multiply by 8. Parentheses are real important. This one I had to multiply by 3x plus 4. Okay? So that gives me 9x plus 12 minus 24 over 8 times 3x plus 4. Notice so much how I don't multiply the bottom together, because I'm waiting to see if something will cancel. And you could just never multiply the bottom together. It's a good habit to get into unless you just need to for a multiple choice answer or something. You're always waiting to see if something cancels. So this is, I believe, 9x minus 12. All right, is there anything in common on the top?
3x plus 4.
All right, so what can I factor out of the top?
3.
A 3. And that gives me 3x. Unless I did something wrong, I'm getting minus 4.
Oh.
Did you think it was 3x minus? Let me
Are
see.
you supposed to distribute the negative sign in the beginning to the bottom?
No.
Yeah, like 3, 8 minus. Oh. No, no way.
So I would
think I factored out like negative 3 from there, so then it was negative 3.
It's really close, but it probably just tricked your mind. You okay on
So,
that?
Yeah.
would you be allowed to leave that one as 9x minus 12 over 24x plus 32?
Yes. I would accept a multiplied version of this. I would accept the factored version of the whole thing. I would accept that. In fact, don't overdo it. But you can call me over and go, am I, what's the word? Is this far enough? Can I leave my answer like this? I won't give you any guidance, but I can say, yeah, that's fine, or no, that's not okay. Don't overdo that though, because a lot of times if I say no, that's not okay yet, it's usually kind of giving you too much of a heads up that maybe you haven't factored out what's in common. Usually people are a lot more confident than that by testing. Okay, any other questions on the sheet? Okay.
No, I was kind of confused with 21.
All right, 21. 21 is 5n plus 5. I'm already thinking that I'm seeing some things in common that I want to get rid of. 35n minus 40 plus 7n. I'm going to reduce a bunch of this before I go on. It's going to make my life easier. It may not help you see where your mistake was, but It'll make our life easier. Okay, so I'm going to factor a 5 out of this because I'm aware that it's in common. And what in the world is this? 35n? Okay. I'm going to factor a 5 out of the bottom. Leaves me n squared plus 7n minus 8. And what can I factor out of this? N. All right, let me pause for a minute. As soon as I cancel out a variable, so far I think all I've canceled out is a number. Now that I've just canceled out the variable,
Can't you take out 5 too?
I'm gonna, yeah, thanks. But this is huge, okay? Over here, I'm gonna cancel out the 5. All that does is stretch and shrink your graph. It doesn't change your zeros or anything, okay? And it's a 5 over 5, so it's really a 1. It won't even affect your graph. Throwing out that n, now this problem is not exactly like that problem, which leads into our topic for today and graphing and blah, blah, blah. If they graph the original, what do you do when you cancel something out? I just threw 0 completely out of the problem, didn't I? Put in 0 for n. Don't you get 0 over 0? Okay? Right, so just be aware that once you start doing algebraic moves, squaring both sides, canceling variables out is way different than canceling numbers out. So now this problem looks exactly like that problem if I type it in my calculator except for at one number. What is that number? Well, it would be 0 comma something, whatever it is. What if I have, what if you and I had been able to cancel out Elena 3x plus 4 and 3x plus 4? Then all of a sudden it would be this cute little 3/8, but it would be 3/8 with a hole in it at -4/3. Once you throw something out like x minus 2, you really just threw 2 completely out of your problem. That's where the hole is, okay? Just be aware of that. Their domains are now a little bit different, but we're simplifying. And now I'm going to cancel these out, and I'm finally going to factor the bottom. You'd have to do this on the front or the back, but I think we'd all agree we'd rather reduce on the front, as Pietro suggested, because if we wait to do it at the end, we might not even see it, okay? I think this is n plus 8, n minus 1.
Yeah.
So Elena's kind of the same. It almost cancels, but it doesn't, okay? If I canceled an n plus 1 and n plus 1, now I'm just throwing out another point, which is not going to happen right now. So my common denominator, I'm going to multiply this one by n plus 8 times n minus 1 n plus 8 over n minus 1. And what do I need to multiply this one by, the front one? By 3. Okay. Now make your life easy. The denominator is 3 times n plus 8 times n minus 1. I'm happy with that, okay? Makes me happy. Because I know that you're ready for pre-calculus, AP calculus. You're aware that, oh, something might cancel later. Why would I multiply all of that together just to factor it all back out again later? It's a denominator. It's fine. The front is 3n plus 3. And here, be really careful here. The 7 doesn't really distribute to this and to this. That's not how you multiply. What if I had 5 times 3 times 2? Isn't that 30? It's not 5 times 3 and 5 times 2. Do y'all see what I mean? I could do 10 times 3. I can like join any of these I want to, but I don't distribute. It's in this situation when you're multiplying. All right, so what I did here was I just said 7 times what I already knew this was. N squared plus 7n minus 8. So I had 3n plus 3, 7n squared plus 49n minus 56. So I have 7n squared plus 52n minus 53 over 3 times n plus 8 times n minus 1, which is the answer. If you want to test the b squared minus 4ac, it's super nice. I was talking to Mr. Hill today about, my, I don't hate the quadratic formula, I just don't care about it. You run into quadratics as easily as you would run into an x cubed or an x to the 7th, which you can't use the quadratic formula on, so I'll be showing you what to do. But it's really nice to know if you can factor. The only time I really factor, you may wonder, like, why don't I stress over factoring more than I am right now? And it's because, mathematicians only factor if it's easy to factor. If you and I can't think of it, it probably can't be factored, and we're just beating our head against the wall. We'll get out our calculator and find the zeros. Do y'all see what I mean? I looked at that. I didn't try to be script on before you see myself, but I just looked at it.
So with the discriminant, you can only tell if it factors if it's perfect square.
Right.
Okay, so if it's like a negative number or not.
If it's a negative number, you're just done. Like, that also won't factor. If it's a positive number, that just means, yes, it does have zeros, but you're not gonna think of them yourself. Okay? Then you could launch in the quadratic formula, but I don't know what good 5 plus or minus the square root of 14 over 7 does to me. I'm still gonna need a calculator to have any idea what that is. So, be smart, mathematicians, and go straight to your account. But I'm glad I have the quadratic formula for b squared minus 4ac and for ACP. So, occasionally they ask some of that. But again, you have a calculator. All right, any other worksheet questions? I would take one more. Okay, if you had some, just email me and we can meet. All right, so next, let me show you what you're going to be doing for homework, and we've already sort of talked about it. Here's an example right here. So I think I'll move Harry down some just for a minute. Maybe I won't. It's pretty insistent. And we'll move this. All right. So now, do you see I don't have a statement like last night? Or whenever you did your homework, like if I cover that up, that was your homework before. Now you've got to solve, which of course the build-up is that you can solve equations, okay? So please, girls, back to what we said earlier. Be aware of this domain on the front end. This is one of the biggest things I can teach you this year. I already can factor that in my head. You can too, I wasn't bragging. X times x plus 1, okay? So I know that -1 and 0 are not a part of this problem. So if it pops up later as an answer, I'm going to go as an extraneous root and just cross it out. It would be a whole or an asymptote or something, okay? But you may wonder, and I spoke about this the other day, well then how did I work the algebra problem exactly right and get wrong answers? And it's because of what I keep saying. I tell you, I was a teacher before this light bulb went up. Nobody ever even told me. It just sort of bothered me, like when I would have to go back and check my answers and all of a sudden I worked it right. No mistakes. Believe it or not. And I would get an answer and fill it in and have to throw it away, whether it was a square root or a fraction or something, okay? The reason is once you take that first algebra step, you're changing the problem somewhere. Most of the time you're limiting the restrictions. Right now I'm about to get rid of the fractions because we all need fractions. Okay? So right now I'm going to get rid of the fractions. Which, girls, if you're just adding them together, if this is not there, and you're just adding them together, you can't get rid of the fractions. You're going to have a fraction, okay? All right, this is the easiest way to do this. You've seen something similar to this, by the way. Okay. So, can you see this white? Can y'all see that okay? All right. So I'm going to write this as 2 times over x plus 1 minus, that minus sign's already scaring me. Minus signs are scary. X times x plus 1 equals 3 over x. All right, please do what I'm about to tell you. Listen to me. Don't tune me out and go, hey, please, okay? Please listen. What some of you would do if you were left to your own devices, which are great devices, but if you were left on your own, you'd probably get a common denominator and cross multiply, which takes longer than what I'm about to show you. The beauty of an equation, if it's an equation, I can just get rid of the fractions and just go on with my life like this in pre-common calculus, okay? So once you know your common denominator, aren't you allowed to multiply something times both sides? Because now you have two sides all of a sudden. It's a seesaw, okay, that we're balanced. You already told these are equal, so whatever you put here, you put here. So I'm going to put the common denominator on both sides and carefully distribute. X times x plus 1, x times x plus 1. Now, I do a lot of this in my head, but you can, and I'm usually more careful than when I'm teaching, which I'm not sure that makes any sense whatsoever. But in any event, there are some people that like to physically write this and now distribute it, like write it down next to both of those. If you have trouble, you want to put this here and this there. On the left-hand side, your left-hand side, I'm about to distribute it mentally, but you might actually need to slap it next to it physically. If y'all know what I mean. I'll come back and say that if you don't get what I'm doing. All right, now I'm going to distribute this. All right, and what happens when I distribute that?
2x.
I get 2x. Are y'all okay with that? Here's my scary minus sign. All right, I've got to be really aware of that minus sign. All right, now I'm going to distribute this. And I'm kind of lucky right now because now what cancels? Everything, and I just have 1. But if it had been a big expression, do y'all see I would need to put it in parentheses and distribute that negative sign? All right, I'm going to finish in yellow if y'all can see that. And then here, what cancels? X. And I have 3 times x plus 1. I just threw a lot out of that problem. But don't you look at that. Look at what you have to do now. Just simple algebra, okay? So now I have 2x minus 1 equals 3x plus 3. That'll give me x equals negative 4. I've been aware from the beginning of the two numbers that were not in the domain, but I'll double check it. I usually don't even check it to see if it's right because I give you so many problems you don't want to do that, but you could. Also, you'll have your calculator for the test. If you have time to go back and check your test, you could like put that into y equals and put it into your y board and see if you get negative 3/4. Table's your best friend. Kind of helps you cheat. Okay, like you're thinking, I wonder what my friend got. You can ask Table. Okay, you can ask your friend. Lindsay?
So why are you multiplying both sides by x and x plus 1? Because like on the right side, it's already like x on the bottom. So why would you multiply it by x?
Well, whatever you put on one side, you have to put on both sides. You want to make it count for as much as you can to get rid of all your denominators. I could have just multiplied this side by x, but if I did that, I'd have to multiply this side by just x, and I'd still have a denominator. I don't want a denominator, so I'm going to multiply through by my common denominator. Okay, like this. I think I have an easier one. I don't like to start off with just the easy ones. Let me do this real quickly. All right, if I have 3 over 7 plus x over 5 equals 1 over 15. All right, Lindsay, we've got some choices here. We can multiply by 5 to both sides. We can multiply by 15 to both sides. Let's pick 15, okay? If I multiply this side by 15, what do I have to multiply this side by? 15. All right, when I distribute, I get 45 over 7 plus 3x equals 1. But what do you see that I still have sitting there? I don't want that. I don't like fractions. I might like them less than you do, okay? So it would have been a little better for me to look at all of the denominators and get my LCM. Do y'all remember that? Least common multiple? Okay? Get the smallest thing you can that'll get rid of everything, all right? And so I think I need a 5 and a 3 and a 7. Do y'all see that? What is that? I think it's 105. So I'm going to multiply this by 105 and this by 105.
Wait,
When
I
I-
kind of forget how to do that. Can you show that again?
I have a 5, a 15, and a 7. 15 is 5 and 3, so I have 1 5, 1 3, and 1 7. Let me give you another scenario. I don't know who I'm talking to. Who said that? Nicole. What if you had 5 and 75 and 7? All right, your factors here are 5, my factor tree. This is 25 times 3 and this is 7. So I need a 7, I need a 3, but I don't need just one 5. I need to take care of all of this for my least common multiple. You've got to actually take the highest power that you see, like that's 5 squared. So if I just use a 5, in this, not that scenario, in this scenario I made up over here, it won't be enough to get rid of it. I need a 25, a 3, and a 7. And then this will take care of that in my common denominators.
Okay.
So you need like, if you have one factor with a 9 and only one factor with a 3, you got to use the 9 to get rid of both of them.
Because 9 isn't like the power of 3.
Right. And if you only use the 3, then you have a 3 left over from the 9 part.
Okay.
Okay? But anyway, back to what I was answering for Lindsay, so not over here. I think that goes in 35 times. What are my factors? How many times does 7 go into 105?
15.
Is it 15?
Yeah.
All right, so this is 15 times 3. What is that one? 21? And this one is what is it? 7? Yeah. Okay, but Lindsay, do you see if I multiplied by this, like factors of all of those, it gets rid of all my fractions. If you do too little, like if I just multiplied this side by x, I've got to multiply this side by x, and when I distribute, I still have fractions left. I don't want that.
So you're simplifying it to like 105 divided by 7 is 15.
Well, I'm going to cancel as I go, though, in my head. I don't want fractions. So I'm never going to multiply 105 by 3. I'm going to cancel it like that, so I'm not having to go to bigger numbers. I'm going to reduce as I go. Okay, let's look at this problem, and it'll keep answering what your questions are. All right, I'm going to factor this. I'm going to take out a 5. This is acting so funny. All right, so this is x over 5, x plus 1, equals 1 over x plus 2, plus 1 over x plus 1, x plus 2. I'm going to multiply both sides of the equation by the same thing. And so, Lindsay, the rule is you have to put the same thing on the seesaw. Both sides of the seesaw are going to be tilted. Okay, so I'm going to put them both here. And I have to make it count for as much as I can. Okay? What do y'all do you see in the denominator? What do you need? Stella?
X plus 1 and then X plus 2.
And a 5.
And a 5. You don't want any of those denominators. Now, what I'm saying here in red is some students have to actually write that there and write that there. It's just too much and too confusing to do in your head. And that's fine. A lot of books actually show you that way. In honors, I just don't take time to do that. Okay? All right, what cancels here? The 5 and the what? Okay, so we're actually throwing things out. And what's left? X plus 2 times x. All right, can you tell what cancels here?
X plus 2.
All right, so I have 1 times 5 times x plus 1 left. And what cancels here? Everything but the 5. 5 times 1. You've kind of got to find your own way of doing this that makes it easiest for you. Don't you love that, though? Now you have an Algebra 1 problem in one moment, as opposed to, can you imagine how ugly this is if you actually get a common denominator and cross multiply? Okay? So this is going to be x squared plus 2x equals 5x plus 5 plus 5. I'm not going to finish this. Do you see you get it equal to 0 and saw? I probably should finish it. I'm aware from the beginning I can't have -1 and -2 as my answers. So I get x squared plus minus 3x minus 10?
Yeah.
No, it's not 5x.
Yes, it is. Yeah, it's negative.
Did I do okay?
Yeah.
Does that look okay? All right, and then I factor, and I get x times x, 5 and 2, minus and plus. My only answer here is negative 5.
Wait, why?
Yeah.
It's positive 5, but why is it not x minus?
Thank you. I love the way you said that. Okay, thank you. Yes, it's positive 5. Your only answer here is 5. Negative 2, I've been aware from the beginning. I can't have that in the original problem.
Zero.
It's 0. If you don't realize it at the beginning, realize it at the end. But the beginning is better. I've known the whole time I can't use negative 2. But I'm going to see it at the end also. Does that make sense? You've got to really watch out for that. Okay? All right. And then I had just an easy one because I feel like I always wanted I liked it when my teacher did some of the harder examples, and then all of a sudden some things were so easy they were hard. Like, don't know what to do with the little bitty ones, okay? This brings up a good discussion, though. We'll work this one really quickly. So I have 1 minus 3 over b equals 10 over b squared. What's your common denominator? You need at least that, right? Okay, you don't need b cubed. You could use that, but that's overkill. So I'm going to multiply this by b squared and b squared. My minus sign hasn't really been in the way today, but always be careful that you distribute it to the back. This is b squared minus 3b. Are y'all okay with that? I think it's the same factors as the last one.
Yeah, it is.
My answers here would be 5 and negative 2, if I got those numbers right. But the only number I'm watching out for here is 0. Y'all see that that's not in my domain. You've just gone through all the rational, vertical, azimuth, and around. Okay, so this has 2 answers. I believe they're 5 and negative 2. All right, so do we have till 11:25? Is that true? Okay. Does let me look at my list. I was going to ask one group to come up and do their problem, and Nicole on my list of things to do. I still have factor in the cube. One day we'll get that. I just keep it on my list till it's done. All right. What group will volunteer to come up and do your problem from the other day? Okay, I've got. All right, so you'll be like on video. You'll be just talking us through. Okay. So let me get you a good slide that you can write on. There we go. Yeah. I tell you what, for now, I'm just going to open up a white slide, girls. Goodness. Is everybody leaving? Did you say you need to go to the nurse?
No, they asked what race it was.
Oh, okay. I thought someone else
So
was
cool.
leaving. Okay. Tap the air. Oh, you're good. You're good.
Wait, okay,
All right.
how do you do it?
All right. Pay
Sure.
close
Yeah.
attention. All of these first problems I gave you.
Wait, what's the question?
It's the second page,
Wait,
the
why don't
first
you just
problem.
write the question?
Yeah, I'll write it.
Harvey, if you want to look at your worksheet, it's worksheet 2, number what?
Yeah.
Number 1.
Oh, look at that.
Worksheet 2, number 1.
I fully don't forget what we're supposed to do. Like, it's fine.
I just know I was supposed to factor and then find the whole or something.
If I don't hand it to you in the next 2 minutes, email me and I'll send you a letter.
Okay, so first what we want to do is factor the equation. So we're going to have 3x minus 2 over x minus 2 and x plus 2. And we can see that these two are the same, so there's going to be a hole at x equals, positive 2. And then to find like the y for that, we have to plug 2 back into the equation, and we get 1.5.
So then the vertical well, wait, okay. We can find that there's a horizontal asymptote at here. There's at y is equal to 3 because the powers are the same. So you just do 3 over 1 is that. And then the vertical asymptote we know is from this is x is equal to -2. And there's no slant and no cross either because if you set it equal to 3, you set 3x over x plus 2 is equal to 3, you get 3x plus 6 is equal to 3x, which isn't true, so no cross. So then, should we draw it?
Okay. Yeah,
or-
and well, we can also find like x-intercepts.
Okay, yeah.
Oh, but there's, I think it's just gonna be at,
0.
but-
They're both at 0 for the x and y intercepts, I believe. Do you want to know that?
draw the
Yeah.
map.
Sure.
Okay.
And to find some points here, I'll putting it back into the calculator. Square root of -4. So 1 positive 1 is a point.
It's only this one, right?
So 1.
1,
And we know that there's the hole at 2, 1.5.
and then the vertical is here.
And then so -3 is a point. Or not -3, I mean -3, 9. Why am I
Okay, so -3, 9, so like
and then
here.
4, 6,
And then
What you're whispering about up there is they found points.
Yes, sorry. I'm looking at this, but there's a point at -3, 9, and then a point at -4, 6, and then over here we found a point at 1, 1, and then
Oh, wait,
0,
we should
0.
draw the vertical asymptote
Oh yes, and then there's at 3.
at 3. Yeah.
1, 2, 3. So you're gonna have one up there. It's something like that's a really bad draw.
That's okay.
And then
then
you'll
here-
have one, yeah.
It goes, and then there's the hole. Oh god.
Okay, thank you girls, great job. Hopefully you got all of that. There's
Yes,
things
sorry.
you got to hear from me. Wait, stop. You don't have to stop. Okay, I always take every shred of time. A couple of important things. The girls were in a hurry, thank you. They found out it did not cross, and so this graph actually would have to skirt along the asymptote, but they were in a hurry. Another thing, and I know they didn't mean this because I know how well they do,